Okay, Aditya, this right here is for you. We are going to find x so that the fractional part of x, the floor of x, and x, they are in geometric progression. Before we start though, we will need to have a convention on what the fractional part of x is when x is a negative number. When x is a positive number, there's no argument. For example, the fractional part of 3.14 is just 0.14. That's easy, no arguments. But when we have a negative number right here, there are actually three ways to legitimately answer the fractional part of x. So let me just write down some note right here for you guys. For example, if we take the fractional part of negative 1.2, this right here, we have three ways to answer it. The first way is the one that I've shown you guys in the past. This right here is defined to be the distance between x and the floor of x, right? Namely, negative 1.2 and the floor of negative 1.2. And if you calculate that, you end up with 0.8. Right, the second definition is that you can just ignore the negative and also ignore just all the integer part. So you get 0.2. That's another way to interpret that. And then the third way is you ignore the whole number part, but you keep this as negative. So you have negative 0.2. So all three right here, they're all legit depending on the situation, I guess. So up to you. But in this video, I will be using the first definition. I will be saying, okay, so I just write this down right here for you guys. We will be using the fact that x is equal to the fractional part of x plus the floor of x. And of course, the fractional part is x minus the floor, right? Same thing. So this is the one that we will be using in this video. All right, so that's the convention. And perhaps if you use the other definitions, the answer, I don't know if they are the same or not. You guys can try it. And in fact, you guys can also try out with the ceiling functions on your own. Anyway, let's be serious now. First of all, we want to have this to be in geometric progression. What does that mean? That means you need to have three numbers so that when you multiply by a number, you can go from here to here, and you have to multiply by the same number to go from here to here. For example, 2, 6, and 18, right? You multiply by 3, that's it. Well, another way to look at this is that if you pick a middle number, which is 6, divided by the previous one, which is 2, this right here has to be the same as this divided by that, which is 18 divided by 6. Of course, you can work this out. They are both equal to 3. So that's the idea. So I use this idea to help us solve that. So let's begin. I will put this down, which is the floor of x. I will divide it by the fractional part of x. And this is equal to x over that. So this is x over the floor of x, like that. Right? So it's the same idea. Well, x, as I told you, we'll be using this definition for either positive or negative situations. So I'm going to legitimately rewrite x as the fractional part of x plus the floor of x, right? And this is actually so nice because you see that on the left-hand side, we have the floor of x divided by the fractional part of x. And this is equal to, well, we can just do this over that, which is the fractional part of x over the floor of x. Ah, very nice, isn't it? And then we add floor divided by floor. You get 1, just like that. Very nice. And notice that this right here is just the reciprocal of that. So now it depends on how you want to solve this. Perhaps it will be easier if we do a little substitution. I will just say let k, and I don't know why I choose k, you can choose r, up to you, but k equal to this right here, the floor of x divided by the fractional part of x, right? So with that, on the left-hand side, we get k, and on the right-hand side, this is just the reciprocal of k, so that's going to be 1 over k, and of course we plus 1 like this. And let's multiply everything by k, and you end up with a quadratic equation, and now clean things up. So on the left-hand side, we get k squared, and then this will be k, so move to the other side, we have minus k. This will be 1, move to the other side, we have minus 1, so this is equal to 0. And then this we can just solve by the quadratic formula. K is equal to negative 1, right? That's the negative b part, which is going to be positive 1, and then plus minus square root negative 1, which is the negative, which is the b, and you square that, which is 1, minus 4 times this and that, which is going to be plus 4, so altogether is 5 all over 2. Quadratic formula, 2 times 1, by the way. Okay, good. All right, now we technically have two choices, right, for the case. So we have to break down into cases. So here we go. Case 1. Suppose K is the positive. And yes, this right here is the golden ratio. So I'll write it down as 1 plus square root of 5 over 2. This right here, it's not x. This is just a k value. So what does this mean? You want to start with right here, multiply by k to get to the next one, and then multiply by k to get to the next one. Well, I will have to do this legitimately. This right here is k, so that means the floor of x over the fractional part of x is equal to k, which is 1 plus square root of 5 all over 2. We like to have the floor by itself because floor is an integer, so it's easier to work with. So let's look at that, okay? So the floor of x, that's equal to 1 plus square root of 5 all over 2. And let me just use the innocent parentheses, okay? Times the fractional part of x, like this. And now to continue, let me tell you guys that this right here is approximately 1.618, right? And then for the fractional part of x, under this definition, we must have the fractional part of x that's in between of 0 and 1, including 0 but not 1. And then you can just imagine we can take this multiplied by this inequality right here. So that way we can get a bound for this right here, right? With that being said, we know the floor of x, this must be, you take this multiplied by 0, which is still 0, and then you take this multiplied by 1, which is that 1 plus square root of 5 over 2. Well, from here, we just have to think about an integer solution that satisfies this inequality. First, 0 works, right? Because you put in 0, it just works out nicely. So the floor of x is 0. In that situation, of course, you have 0 is equal to this times that. That means this right here has to be 0 as well. That means the fractional part of x is also 0. And then, of course, x is just 0 plus 0. It's, of course, still 0. And yes, when you have 0, 0, 0, that's technically a geometric progression, okay? Secondly, let's see, can we find another integer solution right here? Yes, because this right here is 1.618. Well, we know in that case, 1 will work. So let me take the floor of x to be 1. And in fact, these are the only two possibilities from this inequality. And then from here, let's solve for the fractional part of x. Well, if this is 1, I want to solve for this. I can just multiply by the reciprocal of this on both sides. So this is going to be 2 over 1 plus square root of 5. And one little thing for you guys. This right here is bigger than 1. So when you do the reciprocal, this is going to be less than 1. In fact, this is about 0.618. So it satisfies this inequality right here, right? So it works, it's legit. And now, and you can also just do the conjugate on your own, but I will tell you guys that from here, we can get the x, which is this plus that, which is 1 plus 2 over 1 plus square root of 5. And the most amazing thing is, you get back the golden ratio, which is 1 plus square root of 5 over 2. And just add the fractions and then do the conjugate on your own. So it's really cool. This right here, it's approximately 0.618. This right here is 1. And this right here is 1.618-ish. And you go from here to here by multiplying by the golden ratio. And you go from here to here by multiplying by the golden ratio. So cool. Now, case 2. We also have to consider if k is 1 minus square root of 5 over 2. And from here, let me just tell you, this is approximately negative 0.618. And let's see if we can come up with any solutions or not. Well, it's pretty much the same thing right here, so let me pick it up from here, except for we have to use a minus here. So, blah, 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 we get the floor of x equals to 1 minus square root of 5 over 2, and with the innocent parentheses. And then multiply by the fractional part of x. And then same thing that what we did earlier. Let me just put the floor of x in the middle. And I'll do 0 times that, which is still 0. And then I'll do 1 times that, which is approximately this. And Let me just write down negative 0.618, okay, for you guys. It's easier to see from here. And then inequality should go this way, okay? Should go this way, just to make sense. Huh? Anyway, find integer solutions right here. Of course, the first one is you take the floor of x to be 0, and in that case, everybody will be 0. So we have that already. So that's it. And do we have another situation? Nope, no more. Because you cannot find another integer that's in between of negative 0.618 and 0. You cannot, right? So in fact, these two are the solutions. This is it. And if you guys use other definitions right here, you guys can leave a comment down below and let me know what are the other solutions that you can possibly find. So anyway, this is it. Hopefully you guys all like this video, and be sure to subscribe if you haven't done so already. Thank you guys so much. We like to multiply by, we like to isolate the, we like to have the